For more than 40 years, a lone spacecraft has been traveling farther from Earth than almost anything humanity has ever created. It moved beyond the familiar planets, crossed the outer limits of our solar system, and entered a region that once existed only in scientific predictions. That spacecraft is Voyager 2. Launched by NASA in 1977, Voyager 2 was built during a time when computers were far less powerful than the devices people carry today. Despite those limitations, the mission represented one of the boldest scientific efforts ever attempted. Its objective seemed straightforward: explore the outer planets, gather information, and eventually go silent as its power gradually faded. No one expected the mission to continue for decades. As Voyager 2 moved outward, it transformed our understanding of the solar system. It studied the giant storms of Jupiter, examined the ring system of Saturn, revealed the unusual sideways rotation of Uranus, and delivered humanity's first detailed observations of Neptune. These discoveries alone secured its place in space exploration history. But the spacecraft kept going. Beyond the planets lies an invisible boundary marking the outer reach of the Sun's influence. Surrounding the solar system is the heliosphere, a vast region created by the solar wind, streams of charged particles continuously flowing outward from the Sun. Scientists once believed the transition between the heliosphere and interstellar space would happen gradually. Instead, Voyager 2 detected something far more distinct. As the spacecraft approached this region, its instruments recorded major changes. Radiation levels increased, plasma density rose sharply, and the surrounding environment shifted in a relatively short distance. Rather than a slow blend between two regions, Voyager 2 appeared to cross a real boundary. This marked its passage beyond the heliopause and into interstellar space. The discovery changed scientific thinking. The edge of the solar system did not behave like a fading border. Instead, it appeared structured and active, acting almost like a protective shell around our planetary neighborhood. Inside this boundary, the Sun shapes the environment and helps shield the planets from portions of high-energy cosmic radiation. Outside it, conditions become more intense and complex. This realization carries important implications. Earth has existed for billions of years inside this protective region. Without it, the radiation environment around our planet could be very different. Voyager 2 also showed that this boundary is not fixed. The heliosphere expands and contracts with the Sun's activity cycle. During stronger solar periods, the solar wind pushes outward and enlarges the protective bubble. During quieter periods, the boundary moves inward. Voyager 2 crossed during one of these quieter phases, giving scientists a rare look at how dynamic this shield can be. Beyond the heliopause, the spacecraft entered an environment once imagined as empty and silent. Instead, interstellar space turned out to be active and constantly changing. Plasma moves in varying patterns. Radiation fluctuates. Magnetic fields interact across enormous distances. Rather than emptiness, the region behaves more like a vast system shaped by stellar activity, ancient explosions, and galactic forces. Another unexpected discovery involved magnetic fields. Researchers expected a complicated interaction between the Sun's magnetic influence and the surrounding galactic field. Yet Voyager 2 detected a smoother alignment than predicted. This raised new questions. Is our solar system traveling through a more organized region of interstellar space than expected? Or has the Sun influenced its surroundings over immense timescales? Either possibility suggests that space is more connected than previously believed. Years later, another unusual event drew attention. In 2019, communication with Voyager 2 was briefly interrupted. Data transmission stopped unexpectedly before later returning to normal. Engineers linked the event to aging systems, understandable for a spacecraft operating far beyond its intended lifespan. However, measurements taken near that period showed variations in particle activity and environmental conditions. Some researchers proposed that Voyager 2 may have encountered energetic plasma structures or the effects of distant shock waves moving through interstellar space. Others suggested the region may contain features still not fully understood. Whatever happened, the moment highlighted how much remains unknown beyond our solar system. Attached to Voyager 2 is one of humanity's most symbolic messages, the Voyager Golden Record. The record carries sounds, music, greetings, images, and pieces of life from Earth. It was created as a message to any future intelligence that might one day encounter the spacecraft. At the time, it represented optimism. Today, it feels like something more. Voyager 2 carried that message beyond the Sun's influence and into the wider galaxy. In doing so, it became more than a scientific probe. It became evidence that a civilization from a small world once reached beyond its home star. Even now, Voyager 2 continues moving outward. Its energy is slowly decreasing, and eventually the spacecraft will fall silent. Yet its journey will continue long after communication ends. For millions of years, it will drift through the galaxy carrying humanity's message into the unknown. Its achievements are extraordinary. It turned theoretical boundaries into direct observations. It showed that the edge of the solar system is active and structured. It revealed that interstellar space is not empty but filled with motion and interaction. Most importantly, it reflected something about humanity itself. From a small planet orbiting an ordinary star, humans built a machine capable of traveling beyond the sun's reach and continuing its mission across unimaginable distances. Voyager 2 is more than a spacecraft. It is a reminder of humanity's curiosity. And somewhere far beyond the fading light of the sun, it continues its endless journey into a universe that remains vast, mysterious, and still waiting to be explored. Voyager 2 continued moving outward, farther from the sun with every passing year. Distance itself had become part of the challenge. Signals traveling between Earth and the spacecraft no longer moved across millions of kilometers, but billions. A message sent from Earth required many hours to arrive. The reply took just as long to return. Yet despite this enormous separation, Voyager 2 kept speaking. Its instruments continued sending information from a place no spacecraft had explored before. Every transmission carried details about an environment hidden far beyond the planets, revealing that the space between stars was far more active than scientists once imagined. One of the most important discoveries involved cosmic rays. Outside the heliosphere, Voyager 2 detected significantly higher levels of high-energy particles moving through interstellar space. These particles originate from powerful events across the galaxy, including exploding stars and extreme astrophysical processes. Inside the solar system, much of this radiation is partially blocked by the sun's protective influence. Beyond that shield, Voyager 2 experienced the full intensity of the interstellar environment. This observation reinforced an important idea. The heliosphere is not merely a boundary. It acts as a defense system, reducing the amount of galactic radiation reaching the inner planets. For Earth, that protection may have influenced conditions for life over immense stretches of time. Voyager 2 also revealed that interstellar plasma behaves in surprising ways. Scientists once pictured interstellar space as a thin, nearly motionless medium. Instead, the spacecraft detected density variations and changing particle behavior, suggesting a more dynamic environment. Some researchers compared it to weather systems, not with clouds or wind, but with invisible flows of plasma, magnetic interactions, and energy moving across enormous distances. This changed the image of deep space. The universe beyond the solar system was not silent emptiness. It was active. Then came another challenge. As Voyager 2 aged, mission teams faced a difficult reality. The spacecraft's power source was slowly weakening. Voyager 2 runs on a radioisotope thermoelectric generator, converting heat from decaying material into electricity. But every year, available power decreases. Engineers had to make difficult decisions. Instrument by instrument, systems were placed into lower power states. Non-essential functions were reduced to preserve the mission for as long as possible. It became a careful balancing act. Sacrifice some capabilities so the spacecraft could continue operating. Remarkably, this strategy worked. Decades after launch, Voyager 2 was still active. Its continued operation amazed many scientists because the spacecraft had never been designed for such longevity. Components built in the 1970s continued functioning in one of the harshest environments imaginable.